Okay. I would like to make sure everybody can handle the discriminant with two different real roots, because that's, they're all the same thing, right? So tomorrow when you work on page 91, instead of having greater than, you're going to have equals 0 or less than 0, right? But the method is the same. Just put it all the way down, Navleen, please. Thank you. You can move the textbook so it goes all the way. There you go. Look at that. First try, Lego Batman. Does anybody need any of them explained? I heard some people muttering about why this arrow shifted. Why does the arrow flip? Because you're dividing by a negative. It goes back to grade 9. Does everybody understand why this is an OR situation on both of these? Does everybody understand why? Because C looks like this, right? There's 0. The root of 32 is about 4 or 5.5 or whatever, right? So there is the root of 32 positive, so it goes up from there. But there's the root of 32 negative, and it's got to go down from there. That's why it's an OR situation. Does everybody understand this concept? Why it goes on both sides. Why you can't just leave it as greater than plus or minus 32. Root 32. It's got to be greater than the positive one or less than the negative one. Okay? It's an absolute value situation, which you guys haven't been taught probably ever. Because until 2 years ago, absolute value wasn't mentioned until grade 11. And then they took it out of grade 11. And now they're putting it back into grade 11. So everyone's cool with this? Yeah? Everybody? Okay. So I want to take a break from using algebra and now do some calculator practice. By the end of this all, I want you to be able to work in both equally as well. Okay? But to understand what the calculator is doing, you have to understand the algebra. Okay? And when do we use the calculator instead of the algebra? If we have decimals and crazy numbers. If we're using decimals and big numbers, we don't want to deal with algebra. We're going to use the calculator. Everybody cool? All right. So, now honestly, you need to stop me if you're not okay with this. Can everybody get the algebra? Yeah? All right. So if you would all be so kind as to you don't even need to turn your books, but we're back on page 88. And we used our calculators to find all our maximums and minimums, yes? If the parabola, just to remind you, you don't have to write this down. If the parabola looks like that, is that vertex a max or a min? That's a min. If it looks like that, what is it? That's a max. If it's a minimum, my A value is what? Positive. If it's a maximum, my A value is what? Negative. Everybody already knows that from what we did yesterday with the calculators. Yes? Okay. So we have covered all the vertices of all of these. Didn't we, or did we only do the first 3? I can't remember. Did we do all of them? Or did we just do a couple? I think we just did a couple. And everybody should be cool with the concept, yes? Let's just make sure. Everybody take this one, 3a, put that into your calculator, 3a, and tell me the vertex. In proper form, so x comma y. Go ahead, punch that into your calculator. Make sure you can do it. If you weren't here yesterday and didn't practice with these calculators, then you're going to want to pay real close attention when I do this, or you're going to talk to your neighbor. Okay? Everybody try to punch that in. If you don't punch it in right, that's okay. That's what we're doing today. We're practicing. We're learning how to do this. Remember, there's a couple of things you may need to do. You may need to change your window size. The first thing we try is zoom 6. Zoom standard. If it's still not on the screen, then you got to worry about moving your window around. But zoom 6 should take care of all of these. Is anybody ready to volunteer the vertex of 3A? Sophie, the x value is negative 1.5 and the y value is 3.75. Was everybody able to do that? If you weren't, you need not feel bad because you have only done this like 3 times. You won't be good at it yet. I'll wait another moment, and then we'll go over how to do it to remind you. All right. Is everybody ready to see how to do this if you weren't able to get it? Just out of curiosity, how many people got the negative 1.5 and 3.75? So most people got it. Good. But a couple of people didn't. So let's just quickly go over how to find it. There's my graphing calculator. Turn it on. I'm going to enter the equation by pushing y equals. There's my equation. I enter my variable, xt theta n, x squared plus or minus, I can't see it. Plus 3x plus 6. And then I push graph. I'm in the standard window, so it was visible. If it wasn't visible, I would push zoom 6, zoom standard. That's the first place I check. That gives me a 10 by 10 grid. And there it is. Can everybody at least graph the curve? Everybody can do this? All right. Even the people that didn't have their hand up for finding the vertex can do this. Yes? All right. Now, we want our calculator to do some work for us. So we can see right here, calc. We want it to calculate stuff, but it's a second function. Second calc. And what do I want? I want the minimum or maximum. In this case, it is a minimum. Yes? So I push 3 because I want my minimum. Now the calculator wants me to get the left boundary of where I am looking for, right? So I'm going to move my cursor until I am on the left of the vertex. What if I wasn't looking for the vertex? I wanted the minimum value somewhere over here. Then I would just put the cursor over there. You with me? I want the vertex, so I need the value between that boundary. How far left do I have to go? Anywhere to the left of the vertex. So as soon as that thing turns back up, I can stop. You'll notice, look down here, the values are changing, right? Every time I click, I get closer and closer. So once I turn 392, 379, 375, oh, now I've turned back up. So I've gone too far to the right. Does everybody see that? So I'm going to go back a few steps to the left, and now I'm on the left of the vertex. So I push enter. Now it says the right boundary. So now I move to the right side of the vertex. Once I turn back up the parabola, enter. And now it's asking me for a guess, because it's not totally sure it's going to be exact. We want it to guess. And it gave me, this time, it gave me 1.49999999999. That is obviously 1.5, yes? So then I have my vertex, x, negative 1.5, y, 3.75. My calculator gives me the values. Is everybody good? Can everybody do it? Yes? Okay, so here's what we're going to do now. We are going to do the X and Y intercepts for each graph. Okay? And we're going to choose one of these graphs up here. We're going to choose one from each section. We're going to do the X we are going to do the X and Y, not any, the X and Y intercepts for 1C, 2C, and 3C. So what's our first step? Step 1 is to graph 1C. So go up to 1C and get it so it's on your screen. And I chose 1C on purpose because when you're in standard zoom, it's really ugly, isn't it? Right? It's almost impossible to see where the vertex is, isn't it? Right? But I can see that it's somewhere in this area, yes? So that's standard zoom, 10 by 10. Watch what I can do. Does everybody have this graphed? Yeah? Okay, watch. Go to zoom again. Look at all my options. Hit 1. Takes you back to your screen, yes? Use your arrow keys. And notice I've got this little plus sign right here. Does everybody see it on their screen? I'll move it down a little so you can see it better. Ah! Everybody see that floating plus sign right there? Does everybody have it? Put it down in that corner. Everybody's got it there? Push enter. And then push up. Look what happens. I start drawing and then push left. I drew a box around what I care about. Does everybody see that? Now when I push enter, what do you think is going to happen? It's going to zoom in on that box I just drew. Does everybody see what I did? Talk to your neighbor, see if you can figure it out. Okay? Everybody zoom in. Yo. You zoomed in? Yeah, you can zoom in. That's perfect. That'll be fine. Now, guys, when you zoom in, is your picture going to look exactly like mine? No. Why? Because the box you drew might be a little bigger or a little smaller, yes? But what is the point of me drawing this box? Remember what it looked like before? It was like this big. And now we can work with it, yes? Everybody cool? Everybody's got it zoomed in now, yes? Okay, now, it says I want the X and Y intercepts. Now, we have to think back to grade 10 to remember what those things are. The X and Y intercepts. What is every X intercept? No. The X-intercepts are X, 0, yes? And the Y-intercepts are what? 0, Y. We all remember this from graphing lines, right? Okay, so let's look on our sheet, or on our calculator. We want our calculator to do some work for us now, yes? What button do we push for the calculator to do work? Second calc, because we want it to calculate stuff. Second calc. Now, what on there do you think will help us? 1, 2, 3, 4, or 5? 5 says intersect. Does it say intercept? No, so 5's not going to help us. We know maximum, minimum, blah, blah, blah. We know maximum and minimum work with the vertex. 6 is calculus. 1 could help us. So let's see what happens when we push 1. 1. X value. Which of these do we have an X value for? Do I have an X value for the X-intercept, or do I have an X value for the Y-intercept? This isn't a tough question, guys. Do I have an X value? Which of these do I have an X value for? The Y-intercept. The X value is 0, yes? This calculator is asking me for an X value. What will I punch in? 0. And then enter. So what is the Y value, the Y-intercept? 1, because when X is 0, Y is 1. Does everybody see how to do it? So what should we do here? It's 0, 1. And how did we find it? Second calc value X equals 0. Everybody good? Everyone is good? Okay. Now we got to think about the X-intercept. So let's go back to our roots, or our calculate screen. We know it's not 1, we know it's not 3, we know it's not 4, we know it's not 5, and we know 6 and 7 are calculus. What's the only thing left? 2, right? We need a 0. So what happens when we hit 2? What does the calculator ask us? Oh, it asks for a left boundary and a right boundary again. That's weird. Okay. Well, we want the 0, right? So we want to find the X-intercept, yes? So where on this graph is the only place it touches the X-axis? It's right there, right? So I must need to find the left and right boundary around that. Everyone agree? Let's do it. Left boundary. Am I on the left of where it crosses? Enter. Right boundary. Am I on the right of where it crosses? Enter. Do you want me to guess? Of course we do. That's why we're asking you. And what's the x value? Look closer. So the x-intercept is negative 0.2 and the y value is 0. And how did I find that? Second calc 0. And then I use the left and right boundaries. Is everybody cool? That was 1C. Is everybody good? Okay, now we're going to move on to 2C. Now stop for a second. Our calculator right now is zoomed in, isn't it? So when I graph 2C, is it going to be ugly? If I go straight to 2C right now, I'm only going to see this much of my calculator. So what should I do before I start a new question? Go back to standard. Zoom 6. Now we're back at normal. So let's go into our y values. Do we care about this one anymore? No, so we're going to get rid of it. And what are we going to type in there? We're going to type in 2C now. 2C was whatever it is. My computer's frozen. What is 2C? 5x squared minus 3x minus 4 graph. Okay, now let's look at that. Remember, we need the y-intercept and we need the zeros, which is the x-intercept. So looking at this, do you see, can you clearly see where it crosses the x-axis? Quite clearly, there and there, yes? Right? And do we even need to be able to see the y-axis? No, because our calculator does that when our x value is 0. So do we need to zoom in on this, or are we happy? We're happy. We can work with this, right? We could quite easily see left and right of that and left and right of that, right? So let's do this. What are our values for the 2C? Second calc value. Let's get our y-intercept. That's when x is what? 0. Enter. What is it? Negative 4. So our y-intercept, which I've been drawing in blue, is 0, negative 4. Maybe that'll come back. Maybe it won't. Oh yeah, there it is. It showed up way up there. That makes sense. Thank goodness. 0, negative 4. And what are our x-intercepts? Second calc, where do I go? 0. And I'm going to need 2 of them now, aren't I? So I go to the left boundary of one of them. Am I to the left of this x-intercept? So I hit enter. Then I'm to the right of it. So I hit enter, and then I guess. What is my x-intercept? Negative 0.640. Oh, I'm supposed to be doing them in red. And then I go to the other one. Second calc 0. Am I left of it? Am I left of it? Now I'm right of it. And I get 1.24. Can everybody do this? Okay, guys, don't talk to each other. Talk to me. Can you find these? When I say can you find these, all you need to do is say yes or no. I just need to know how many people are able to get this and how many aren't. Yes, of course we will. But I need to know. But when I ask, who can you get this? I get this. You're talking to each other. I don't know what that means. The exact same way I got the 1.24. If you got 1.24, you got the negative. You should have gotten the negative. Second calc, 0, right? Now, here is an intercept, right? So I need to be to the left of that intercept. So here comes my cursor. Am I now left of that point? So I hit enter. Now I need the right boundary. So now I go right of that intercept. Have I gone to the right of it? Enter. Guess. Negative 0.64. You don't need to. You just need to go to the left and the right of it, just like we did for the vertex. Then on the other side, you got to go left and right of this one. There's 2. Yeah. That's how you got the 1.24. Is everybody good? I need to get you guys little signs with a red light, a yellow light, and a green light, like grade 3. I don't understand why they do that in like grade 3. Kids in grade 3 don't care. They just want to talk. I get it, teacher! You guys, do you get it? Do you get it? Do you get it? You guys need the signs. Then you can hold up a green, yellow, or a red light. All right. Everyone is good? Okay, we're going to graph a new equation. What should I do? Am I already in a standard window? Okay, so let's graph C. Or 3C. What was 3C? 4x squared plus 2x. 2x plus 1. Yeah? Graph. Okay, it's on the screen, right? Kind of hard to see. We could zoom in if we wanted. Second calc. I want my value first. That's the easy one, right? When my x value is what? 0. My y value is what? 1. So for 3c, put it up there, of course. Why wouldn't it? 3c, I have my y value, or my y-intercept is 0, negative 1. Yes? Now look closely. 0, positive 1. Thank you. Look closely. Does it touch the x-axis anywhere? So does it have an x-intercept? No. No x-intercept. Which we already knew from the discriminant, right? It had no roots. It had no zeros. So it never touches the x-intercept. X-axis. Everybody good? Everybody can use their calculator? Everybody can use the discriminant? Now you guys are smart kids. For 2c, I got those values, didn't I? Right? Everyone agree? Watch. 2c, my values were negative 0.64 and positive 1.24, correct? 5x squared minus 3x minus 4. That was the equation, right? Doesn't factor, does it? Doesn't complete the square, does it? So we would quadratic formula that, right? 3 plus or minus the square root of 9 minus 4 times negative 4 times 5 over 2 times 5. Yes? 3 plus or minus the square root of 89 over 10, right? Right? Three plus square root 89 divided by 10. 1.24, 1.24. Everybody see? The roots that we found with our algebraic method, the calculator found with the graph. Is everybody cool? Now, obviously, if I punched in 3 minus root 89, I would get this one. Is everybody good? Can we all work the calculator? Do you want to try one totally on your own? All right, let's do so. I'm going to make up a question, and you guys can just try to punch it in and see if it works. Everybody ready? Okay, let's go with 6. No, let's do a crazy one with decimals, so we wouldn't even try quadratic formula. Let's go negative 4.9 q squared plus 18.2 q minus 5. I want the vertex, the X intercepts, if there are any, and the Y-intercept, all from your calculator. Go, talk to your neighbor if you need to. Zoom 6 is going to cause you some trouble. Of course you can change just the window. We talked about that yesterday. What needs to change on the window, Max? Everybody make sure you write down the vertex, the X-intercept, and the Y-intercept. And then I'll show you and you can feel good about yourselves, or you can say, Mr. Myers, I still don't get it. Yes.
Are you getting the error on this like error?
So what are you looking for now?
0 right now.
You're looking for a 0?
Yeah.
So second, calc. Yep. So you need the 0, so you need to be on the left of that where it crosses the x-axis, right? Right? So right now your y is still positive. Have you crossed the x-axis?
No.
Because when you cross the x-axis, that's y going to be 0, yes?
Yeah.
Or negative, yes?
No.
So is y 0? Is y negative? So am I to the left of that x now?
Yep.
So I push enter. Then I need to go to the right. Am I to the right of it? Is that positive?
Yep.
So then I push enter. Then I push guess. That's my 0, 0.298. Okay?
Okay.
That's one of them. Now I need, there's a second one, isn't there? Second, calc, 0. But this one's way over here. Am I left of it? Okay, enter. Am I right of it?
Yep.
Enter. Yes. 3.41.
What? This
Who? Doesn't matter.
Okay.
That's -1 times 10 to the -12, which is 0.00000, 12 zeros, and then a 1. It's 0. Are we ready? Okay, no rush. Alrighty. I am seeing a range of faces from this to, okay, which means some of you are, holy crap, I can't even draw it, to some of you are like, I got this. So, let's start from scratch. Could everybody get to here? They were all able to draw it in a standard window. Was everyone able to do that? Okay, I'm not asking what your calculator said. I'm going to say this slower because people are having trouble with my question. The answer to this is either a yes or a no. That is all I require. Could you draw this curve in a standard window? How many people say no, meaning you cannot get this on the screen? So I'm going to do this again and see if maybe you can figure out my complicated instruction. Put your hand up if you cannot draw the curve. Okay, so if you cannot draw this curve, then your equation is wrong. Negative 4.9 x squared.
Oh, I know. I forgot to put a number down.
Great. You must have this variable. I used Q on purpose, right? Because your button on your calculator does not show Q. It shows X, T, theta, and N, which is the button, could your calculator button be big enough to put every single thing you could put in for a variable? No, because there are infinite things you could put in for a variable. So you have to push that X, T, theta, N button. That's your variable button. So everybody make sure you have punched this into your calculator screen. Negative 4.9 variable squared plus 18.2 variable minus 5. Then push graph, and you should all be looking at this. So if you weren't able to draw the curve, make sure you get the curve on your screen now. That is step 1. What is wrong with our drawing now? You cannot see the vertex, can you? Jaskirit, is the vertex above or below on the screen? It is above, so we need to change our window to see more up, yes? What is up and down, Y or X? Y. So I need to go to my window and increase my Y maximum so I can see the top of the curve. I am going to try a Y max of 20. Then I push enter. Then I push graph. Now can I see my whole curve? Can everybody get to there? If you cannot get to there, put your hand up. All right. Now, I want the vertex. Is this vertex where the red circle is a maximum or a minimum? It's a maximum. Good. Everybody heard my voice. So I'm going to get my calculator to second calc for me a maximum, which is 4. Now it says I need the left boundary. Am I allowed to put it anywhere to the left of the... Is my cursor on the left of my vertex right now? Right where it is? It is. So can I push enter? Sure. Now I need the right boundary. Is my cursor to the right of my vertex yet? It's flashing right there. Is that the right of this peak? Yes or no? No. So I need to move it until it is to the right. It's getting close. It's getting close. Look at the Y values. 11, 11.7, 11.8. Oh, now it's going back downwards. So have I gone over the top? So now I am to the right of my vertex, aren't I? When am I allowed to push enter? Anytime I'm to the right. I'm going to move it a little more just so you can quite plainly see I've gone to the right. Enter. Calculator. Would you like for me to guess, sir? Or ma'am? Yes, I would. My maximum is 1.85, 1.86, and 11.9. So my vertex is 1.86 and 11.9. Does everybody see? Can everybody do it? All right. Now, what's the next thing I'm going to find? Do I have to find this stuff in this order? Of course not. I'm going to get that second calc. I'm going to get that value out of the way because I know that the Y-intercept is when x equals 0, yes? So I can go value x, 0. Ha ha, easy peasy lemon squeezy. Enter. What is it? -5. Now I need my zeros. Second calc 0. Am I to the left of this x-intercept right now? Yes, how do I know? Because my y value is -5, right? So I'm going to hit enter. Now, when I move to the right, what happens? As soon as I cross the x-axis, what's going to happen to my y values? They're going to go positive. Have they gone positive? So can I push enter? Would you like me to guess? Oh, please do. What is my x-intercept? One of them is 0.298. 0.3 would be fine. Everybody cool? Now, is there another x-intercept? Yes. So I go second, calc, 0. Now I need to get to the left of it. Am I to the left of that x-intercept right now? Look at my flashing cursor. There's the x-intercept. Is my cursor on the left? Yes, because my y values are positive. Enter. What is the right boundary? Soon as those y values turn what? Negative, I've crossed the x-axis. Have they turned negative? So can I hit enter? Would you like me to guess? Please do. 3.41. 3.41, and the y value is 0. Can everybody work their calculator? Should you be expecting to work your calculator perfectly today? No. What will it take to work this? Practice. As much practice as you choose to do. Is everybody good now? At least to the point where you can draw a curve and do some calculating and move your window around. Everybody? Sweet. All right. I need a calculator break because I don't have enough hair to pull it all out right now. Everybody flip to page 94. I made a mistake this year. I changed it up a little. I thought that it might work better to let you see your calculators first so you could understand about the curves and what happens with them. That was obviously a mistake. I should have done all the algebra first and then let you have your calculators. My fault, not yours. So, we're going to put our calculators aside right now, and we're going to talk about quadratic functions. Okay? Every quadratic function, every single one in the entire mathematical universe follows this pattern. Y equals x squared. Every single one. Any other numbers that are on the right-hand side of this equation, just change what this curve looks like. It will make it wider, narrower, or upside down, or move it all over this. Is everybody cool? So, that means if every single parabola in the whole world, the whole universe, follows this pattern, except it's changed from this pattern, then if we understand this guy, we should be okay, yes? So let's graph this guy. How would you graph something if you had no idea how to graph it? Now for lines, you know point-slope form, you know slope-intercept form, you know x-intercept and y-intercept form. You got lots of ways to graph a line. But when you were first learning about graphing lines, what did your teacher do to make you graph it? You made a table, a t-chart, yes? Some of you called it a table of values, some of you called it a t-chart. It looked like this. X and Y. Which of those was input? Who made the decision? You did. And do you put in X's or Y's? X's, because X's are an independent variable and they are our input. Yes? What numbers can we put there? Any numbers you want. But if you're smart, you'll put a few on both sides of 0. So let's put -2, -1, 0, 1, and 2. When x is -2, what do I put there instead of x? -2. So what is -2 squared? +4. Yeah? Excellent. What is negative 1 squared? Positive 1. What is 0 squared? 0. What is 1 squared? 1. What is 2 squared? 4. Now, graph it. We have a point at 0, 0, yes? The next point is at negative 1, and I'm going to come way out here and go up 1. Is everybody cool with that? That is negative 1, 1. Yeah? And then I have another point here at 1, 1. Yeah? What's the next point? I got to go out 2 and up how far? 4. Two, 4. And then I got to go out to negative 2 and up how far? And then I get this nice curve. Does everybody understand that? Everybody cool with those 4 points? Now we know from graphing that unless we put some rules on this, that curve is going to go on forever, isn't it? So, I started at 0, 0, I went right 1, and I went up 1. Yes? Then I went right 2, and I went up 4. What is going to happen when I go right 3? 9. Right? What is going to happen when I go to negative 3? 9. What is going to happen when I go to positive 4? 16. What is going to happen when I go to negative 4? Positive 16. What is going to happen when I go to negative 7? 49. What is going to happen when I go to positive 7? 49. What is going to happen when I go to x? I'm going to change by x squared. What is going to happen when I go to negative x? I'm going to change by x squared. Does everybody see the pattern? Every single parabola follows this rule. All right? So, from the vertex, an increase or decrease in the independent variable results in that same change squared in the dependent variable. So what does that mean? If I go 1 right, I go 1 up. If I go 2 right, I go how far up? 4. If I go 3 left, how far up? 9. If I go we're going to leave it like that, and that is all for that kind of parabola. What do you think happens if I flip it over? So now y equals negative x squared. Will 0, 0 still be on the list? Okay. When x is 1, what is y? What's 1 squared? But there's a negative out in front of it. So when x is 1, y is negative 1. What about when x is negative 1? Y is still negative 1. Because negative 1 squared is positive 1, but then there's a negative out in front. What about when x is 2? to negative 4. What about when x is negative 2? Still negative 4. So either I'm going, the rights and lefts don't change, but the up and down changes, depending on that symbol, which we already knew from earlier lessons. Is everybody good? And every parabola follows these rules. Every single one. Cool? All right, let's talk about that. Oops. What is the vertex? We're going to do some vocab here. Put that word into regular English. Because when I draw it, all of you can tell me where the vertex is. Where is it in that one? I'll put 3 dots on here. A, B, C. Where's the vertex? B. Okay. What about this one? Q, R, S. Where's the vertex? R. Right? Everybody good? So let's put that into regular language. The vertex is what? The highest, which is a maximum point. On which axis, the y or the x? On the y-axis. Or it's the lowest, which makes it a minimum. Is everyone cool with that? Okay. Now, the equation of the axis of symmetry. Ooh. Think back to grade 9, possibly grade 7. What does symmetry mean? It balances out. It's the same on both sides, yes? So, I'm going to draw a curve. There's a parabola, yes? There is the vertex, yes? Where could I draw a line that would cut that parabola exactly in half? Could I draw this red line? Or would I draw this green line? It's the green line, isn't it? Because if I were to fold my computer in half, this black line would hit there, wouldn't it? So, the equation of the axis of symmetry, computer frozen, we'll just wait a moment. First of all, the axis of symmetry is a line, whoops, I don't want to say line, sorry, a vertical line through what point? Well done, Max. Through the vertex. Now, what's the equation of that line? If it's vertical, is it x equals or y equals? Think back to grade 9 again. It's a vertical line, but it goes through the x-axis, doesn't it? So the equation is x equals something. Right? X equals a number, because vertical lines are x's. How do I know what it is? It is x equals the x coordinate of the vertex. Does everybody follow me with y? Does everybody follow me with the reason there? If I tell you that that vertex is at 0, 0, and the vertical line that goes right through that vertex is where x equals 0. Is everybody cool with that? Okay, what are x-intercepts? What are they in regular English, and what do they mean? What is an x-intercept? In regular English. Sophie. Right. Anytime the parabola crosses the x-axis. How many options are there? Can it cross no times at all? Yeah, you can have 0 intercepts. Can it cross once? Yeah, because it can bounce off. You can have 1 intercept. Can it cross twice? Can it cross twice? Yeah, you can have 2 intercepts. They have another name. They are also called roots. They are also called zeros. Because it is when it is at x, comma, 0. Is everybody cool with that? Yeah? Okay. The Y-intercept. What's the Y-intercept? In regular English, what's the Y-intercept? How many times can that happen? Think about it. How many times can a curve cross the vertical line? Only once. There's only one. And where does it live? When x is what? The x-intercepts are x0. What's the y-intercept? 0y. Is everybody cool to there? All right. Now, knowing what you know about regular parabolas, what is the vertex of the basic parabola? This guy, y equals x squared. What's the vertex? What's the vertex of this guy? 0, 0. Excellent. What's the equation of the axis of symmetry? X equals 0. What is the x-intercept? How many of them are there? 1. At what point? The x-intercept is 0, 0. What is the y-intercept? 0, 0. Can everybody find all 4 of those points on a regular parabola? Yes? Okay. Then we're going to do the last thing we're going to do today. We're going to talk about domain and range. What is domain? Who can remember? It is all possible x values. What is the range? All possible y values. So I have this line, yes? Oops. This is the parabola with which we are working. Y equals x squared. Can I put every single number in the universe in for x? Yes or no? Yes or no? Yes, because I can square every number in the universe, yes? So my domain, x, is a set of real numbers. You remember that symbol from grade 10 if you were in my class? All the real numbers can go in for x, because no matter what it is, I can square it, yes? What is my range? What are my values for y? What will happen to this parabola as it goes this way? How far up will it go? Forever. How far up will it go here? Forever. Will it ever go to the negatives? So y must be greater than or equal to 0. Is everybody cool with that? This is math. What about physics? A parabola in math class has all the x values and those y values. What about physics? There's restrictions, aren't there? In real life has restrictions. If I throw a ball off a building, it would follow this path, yes? I throw it, it would go out and down, yeah? Does that make a curve? Is a curve a parabola? Excellent. Could I have any values over here in real life? No, because I threw it off the building. I didn't throw it from over here. Can the ball dig into the ground? So could I have any values down here? So in real life, I have restrictions. Math class? No. Real life? Yes. Is everybody good? Yeah? Everyone is good?
Yes.
Okay, listen to me. You have a test. Your cumulative test is tomorrow. It's got none of this stuff is on it. Okay? If you finish tomorrow, I want you to do, I wrote it down somewhere. Where did I write it down? If you finish your cumulative test, I want you to start on page and do pages 92 to 93. We skipped them today. Do not do them tonight. Study for your cumulative. This is what I want you to work on tomorrow if you finish your cumulative. What if you don't finish your cumulative early? When do I expect to see that done? Thursday. If you have a calculator, come and get your phone. Make sure you take your phone, not somebody else's, or your house key, or whatever it is.